Hello and welcome to our webinar about zones. So what do we want to shed a light on in this webinar? This webinar is going to be about zones and what's in it for you and why they are so important for every fleet management solution. So let's look at the different types of zones that are existing out there. We have the instance of our fleet manager over here, which supports zones. There's different types of zones, as I said. Like one of them is zones that are evaluated directly by the fleet manager. That's, for example, a limited capacity zone here. Or also it could be another zone that only lets vehicles be assigned to a process if they are in a certain zone. The second type of zones is zones that can be forwarded to the vehicle itself. Our VDA 5050 Fleet Manager, in addition to the standard, also offers the opportunity to send zones to the vehicles. Because the more modern vehicles are, the more they can do on their own. For this, they need to know where they are allowed to do what, and that's why we're also able to send those zones to the vehicles there. And the third type of zones that we like to use is the zones that are evaluated by a real-time localization system. So it's like a combination of the fleet manager zones and the zones we send to the vehicle. But the difference is those kind of zones refer to the actual location of the vehicle. With that information, we are able to trigger other logics. For example, we can also incorporate forklifts with that. And those forklifts then can be used in order to do a collision avoidance there. Because very often with the forks of the forklifts, they lead to accidents and there is problems with the forklifts because the robots usually have scanners, and those scanners are usually in a height where they not always are able to detect the fork of the forklift. In that case, the robot drives into the fork of the forklift and is not able to continue to drive. That's also a big problem that leads to high maintenance effort on the forklifts. Another example of the third type of zones is the zones to create some logic. For example, we can set traffic lights based on zones. If a vehicle, for example, goes into a certain area, we can detect it and automatically set traffic lights. So forklift drivers around know that they cannot enter that area, but also the other way around. We can set virtual traffic lights in the fleet manager based on the position of a forklift or another asset. And based on that, we are able to build very intelligent logics based on the position of certain assets on the shop floor. The interesting thing is, it is not only very, very important for very modern robots that have a high degree of autonomy and need the zones to understand what they're actually allowed to do, but also it's like a Gaussian curve. Also the older robots, it could be very relevant. That might be not yet VDA 5050 compliant. So why is it also important for the older robots? Well, if you don't have a VDA 5050 interface, it means that you don't know too much about the robot. That means you don't have like a full control over the robot. And you sometimes cannot do that because the interface might not be available or cannot be built by the manufacturer. So what do we do in that scenario? In that scenario, we can put zones in front of intersections, and in front of those intersections, it is possible that we set traffic lights again. So the old fleet of the old robots, where we cannot do much, but maybe just pause, resume them, and get their location, those request to enter an area, and we see if our fleet manager already requested the area as well. And if it requested the area as well, we pause the old vehicle and let the new vehicle drive through. As soon as the new vehicle, which is managed by our fleet manager, left the area, the old vehicle is allowed to drive again. The other way around, if the old vehicle approaches the shared area first, it would request the area, and if it is free, it would set a virtual traffic light in front of the area to the vehicles that are VDA 5050 compliant and stops them right in front of that area. And this is not the perfect solution for vehicles, but sometimes you do not have the choice that the vehicle can talk with a standardized interface or or the manufacturer maybe cannot offer you any more information than the position and pausing and resuming the vehicle. So that's a good solution there to incorporate it in a process. Also, we can, based on that information, have another advantage, because if you don't have to transform the whole logic of the old robots into the new system, the integration effort is much lower, and you can rely that your operations continue to drive as they drove before. Of course, it is in most cases preferable to also fully integrate the robots, which we also do on VDA 5050, or a proprietary interface. But as I said, it's not always possible, because if you want to do that like in a reliable and serious way, you of course have to test a lot and so on. And if the manufacturer does not have an interest, the AMR manufacturer does not have an interest in doing that, you might have to go to the zones approach, which also has its upsides. Okay. Let's look a little bit into the fleet manager. So what can we do here with zones? Well, first of all, we maybe talk about the types of zones that we have here. So we have different types of zones. And in a VDA 5050 fleet management system, you of course always have to have different types of vehicles, because you might have different manufacturers with different vehicles, and they might need different logics. Okay, let's check a little bit what we have here. So we have a limited capacity zone. A limited capacity zone is a type of zone that's very important for controlling your traffic, because you have areas where you sometimes only want to have one robot at the same time, because the robots are, for example, turning a lot there, and there's a lot of problems otherwise with the robots if they cannot turn in that case. So the limited capacity zones are very important, because sometimes you have an area where only one robot can be at the same time because it turns a lot there, and they might get into the safety fields of other robots. But on top of that, you can also use this for process stability. You can, for example, select that only a certain amount of vehicles, maybe 2 or 3 or 4, can be in one process step by setting a limited capacity zone over the process step, and like that you can control your fleet. This zone is fully evaluated by the fleet manager, and the fleet manager takes care for you with it. The second type of zone that we have is a restriction zone, the red one here in the background. What's the point about restriction zones? Well, it's a scanner thing again. You know, the robots have their eyes. The eyes are their scanners, and those scanners are often like in a height of maybe 10 centimeters or so. And now if you have like a step that has a height of, I don't know, 7 centimeters, they will not detect it, because the scanners are in most cases 2D scanners. So if the robot has a little bit of autonomy, and it can, for example, do obstacle avoidance or something like that, the vehicles will likely try to drive over that area because it doesn't detect there's an obstacle. And by us forwarding the information about those zones to the vehicle itself, we have like great opportunities to avoid this kind of damages, because we send to the vehicle information, hey, this is an area, even if you detect it's free, it's a no-go area. You cannot go in there. And that avoids them driving over the step that I described before. Okay. What else do we have? Well, vehicles do obstacle avoidance, especially more modern vehicles can drive around obstacles dynamically and adapt a route about it. Well, you don't always want to do that. For example, if you have like tight hallways where you see, okay, it could be complicated that they get around each other, or they get stuck while trying to do obstacle avoidance because of difficult circumstances on the shop floor, you can activate or deactivate that behavior via setting a zone over that area that is sent to the vehicle, and the vehicle knows, okay, usually I can do obstacle avoidance, but maybe here it's not a good idea in this area. So they don't do the obstacle avoidance there. So that's incredibly useful as well, because it is based on the actual position and not just on a graph. Yes. Also, in some areas, you want to turn off or turn on cameras, because the cameras are often used to have an additional safety layer, which lets the vehicle stop or slowly break down towards some area. And yeah, that behavior might not always be desired. So the vehicles often have like a tolerance in which they can drive in an open area, where we talk about some centimeters. 5 to 10 centimeters is quite common, that the vehicles have like as a tolerance to drive around the points and so on along the line, because precision and speed is often difficult to unite together. So in the free drive on a free area, they usually have like a higher tolerance than if they're trying to find position under load carrier. If you have 5 to 10 centimeters, you're driving 2 meters per second. This is quite useful that you have a camera that already warns you a little bit earlier than your safety fields come in, so it slowly breaks down instead of going into a safety field violation. But that's not always possible, because sometimes you have a load carrier, or most of the time actually you have a load carrier, where you have like a tolerance of 10 millimeters, like 1 centimeter. And if you drive under those, the cameras might detect it as an obstacle and the vehicle might stop, for example. And with this kind of zones, like the machine safety zones, you can tell the vehicle that even though your camera might detect something, please rely on your laser scanners instead and don't use the camera in that area. So you would turn on and turn off the camera in those areas, which is also a really big improvement for process stability if you're able to give that information based on the position of the vehicle. So what else do we have? Well, we have the coast zone. I'm going to come to that a little bit later because it's like a very, very advanced behavior. Also, we have fire alarm zones. Fire alarm zones are evaluated in our system, in the Fleet Manager. So what can we do with those fire alarm zones? Well, if I have a factory and the fire alarm rings, I usually want driving operations to stop, but not everywhere. And with the fire alarm zones, I can mark areas in which I don't want the vehicles to stop, so they don't stop in that area, but rather on the first point after the area. And with that, you can very easily build up yourself like the areas where there's fire alarm logics, and stop the vehicles only outside of those areas in case we have the emergency with the fire. Also, we have condition zones, which is really, really nice. Because often when I have like several load carriers next to each other, like how we see it here, for example, or up here, where there's several positions in an area, and the moment I start an order, it might be in a different state than when I arrived there, because in factories we see often that the robots drive around like for 5 or 10 minutes or so, and they want to drop a load, for example, in an empty spot in that area. The moment I started, it was maybe the left spot. But the moment I arrive here, it's one of the middle spots. And with this kind of zone, you can actually say, select the spot that's currently free. So maybe on the last point before the robot drives in here, the robot would decide, the AMR would decide which one of those points is free, and the Fleet Manager would update the order in order to send the robot to the free spot. The condition zone can not only be used for the detection of load carriers or for the replanning based on a sensor in the high rack, which space to take, but also for the traffic. You can, for example, say, okay, I have a condition. If a vehicle is in a certain area, please update your order and drive around. If you have 2 parallel hallways, usually the left way is always 5 meters shorter than the right way, so you go to the left way by default. But if there's something in the way, you know someone is dropping off something in that area, some vehicle is dropping off something in the area, you rather want it to drive around because you know waiting behind the other one because of the traffic will be slower. So you can set up a zone for that area and say, hey, if there's something in that zone, if there's a robot driving around in that zone, please drive around. That's also very, very useful because it can increase your process efficiency while having a very, very high predictability because you know what's the conditions behind it and why the robot would drive around in such a scenario. And there's other things that you can do with the zones. There's like those speed limit zones. That means like we can set a speed limit to all paths in an area. So we always let a vehicle drive slowly in an area, which is pretty nice because it can be enabled and disabled. So you could also have like a logic where you have like adaptive speeds depending on which zones are enabled. So I have maybe 2 or 3 speed limit zones above each other. And if I have like a production speed of a line that is usually, I don't know, 0.1 meters per second, but then I have a situation where one part of the line has to catch up because one other step was a little bit slower, then I can just activate the 0.2 meter zone and deactivate the 0.1 meter zone, and the vehicles would drive faster in that area then. which can be incredibly useful to adapt or catch up in scenarios like that. Then we have another type of zone, a disable point zone. What can we do with that? We can disable areas for route generation. So that means if I, for example, have a maintenance in an area, or it is not fit to drive, or I'm cleaning it right now, I might not want my robots to drive into that area anymore. So if I put a disable point zone, or already pre-selected, pre-made disable point zone, and I just enable it, I have the opportunity to actually adaptively give the right to go into the area, or actually telling the vehicle that this area is like a valid route. Otherwise, I can exclude it, and all routes are planned around the area. So that's also very, very useful to do that, because in every factory there's like cleaning or stuff like that happening. And in those situations, it's always messy. And if you can just exclude that area while the cleaning is in progress by just enabling or disabling that kind of zones, I think that's like a very, very valuable asset that is also very valued by our customers that you can do there. And let's come to the last zone that I see here. It's the assign zone. The assign zone allows us to assign orders only to vehicles that are in a specific zone. That means if I have a process, and maybe I have like an area where I want to pick up something, and then I have an area where I want to drop off something. But my charging stations are close to the drop-off area. So the robots, by the charging strategy, would rather park around the drop-off area. Well, it doesn't make sense to drive to the drop-off without having anything loaded. You always want to maximize the time your vehicles drive with a load on it, with a load carrier on it. So what would you do in that kind of scenario? Well, you could, for example, have like parking lots close to the pickup area and send the vehicles after the pickup job to those parking lots. The interesting thing then is you can say it's an assign zone there, and all jobs that start at the pickup area can only be handled by vehicles that are in that zone. Like that, I can avoid that the vehicles from the charging station drive all the way to the remote pickup area, and they only start picking up in the area where they only start their jobs if they are close to the pickup area there. And you can really, really nicely control that with a high flexibility, actually. Because there's also the other scenario where you maybe don't want that behavior, that it is only a robot that's close to the area that takes the job. For example, if you have like a factory with a centralized charging and parking area, and all vehicles are responsible for all transport jobs. So you need to be able to adapt the fleet management system to your process, and zones like the assign zone are a perfect tool for that. So there's one more thing I would like to show about zones. As everything in the KINEXON Fleet Manager, you can also create zones on your own in the fleet management system itself. And it's very, very simple, because you just can do it on the map. And I can create a zone here like this, like this, like this, like this. And then I say like restriction. And then I have a restriction zone, and I can put it in here. What's the interesting thing about the zones that we use? Well, the types that we have also can have parameters. For example, the condition zone, maybe you want to check if there is a load in that area, or if there's a vehicle in that area, and so on. The speed limit allows you to set like a speed. The limited capacity zone allows you to set a capacity. And like that, you can give incredibly much information to the robot. And if you're talking about VDA 50/50 projects, or in general projects where you separately have like the fleet manager and the vehicle, it's always important that you have a quick way of transporting information from the fleet manager to the vehicle with a high level of customizability. Especially, for example, those things like adding those parameters to it, because you can give them more information about the environment. And that helps the robots a lot, because you can just make them smarter. And it's just another way of passing information, but linked to a location. Because in the end, a good system, yes, the graph model works good in the VDA 50/50. But the more we think in the future, the more the robots will have more and more autonomy. And the AMRs will also make more decisions based on that. And that's always linked to zones. That's linked to areas. And they will detect, is there 3 areas to drive? Or should I take route A or B? And exactly for that kind of logics, zones are crucial because they don't just follow a straight line or so, but they might do an obstacle avoidance on the way, or they might do something like decide if they should go left or right in the long run, based on those coasts, for example, or on obstacles and so on. And this whole line with deactivating certain features, but also being able to attach coast to certain areas really is a way in the future. Because if I have like certain areas and I want them to prefer like a big road over a small road, I can still attach higher coast to the small road than to the big road. So in most cases, the robots would take the big road, and only if the big road is quite full, the cost of the big road would get so high that the smaller road is chosen by the AMRs. And yeah, it's totally exciting where all of this is heading. And we use it a lot, the zones feature in the installations with our customers, because it just enables us to be much smarter than just having the points and paths, which also works good. But it just does not give you the opportunity to monitor logics or build logics based on the location of the robots. And that's why it's crucial to have zones in your fleet management system. So let me sum up. What's the main advantages of zones? First, you can build logics based on the location of load carriers, based on the location of forklifts, based on the location of AMRs. That's extremely useful. The example I showed there was like you can avoid collisions with forklifts. That's one thing. Second, process compliance. With the zones, if you, for example, track your load carriers, you can, for example, create orders into the fleet management system. That means you know how long was an asset in a certain area, and then it automatically triggers the order and how long did it take until it was in the next area. So you have a comprehensive overview of all your load carriers in the factory if you combine it with a real-time localization system, like KINEXON OS, for example. So it's very important to think into the future here, because more and more logics will build on exactly that. And as I said, the last thing is the zones give the fleet manager the flexibility to very easily set up behaviors in certain areas, because they can just say, okay, in all of that area, I want to have a speed limit. Or in all of that area, all of those points should be disabled or stuff like that, because you actually shouldn't care that much about the points and the paths, but you want behaviors in areas. And zones are the modeling layer that are totally crucial to it, because otherwise it's going to be so much clicking to set everything up. And in the long run, you need it anyways for the robots that need more autonomy. And exactly for that, we offer zones. I hope this was insightful for you and it helps you. So thank you so much.